Okay, guys, this video is going to look at problems involving time, distance, and speed. You'll see there's a warm-up question here. I'm not going to do it in this video. My only hint here, solve using any method. You want to simplify first. Always try to simplify the problem before going through and try and solving it. Here, you could simplify first by clearing the fractions. Right? If those equations didn't have any fractions in, meaning multiply everything up top by 2, that becomes an easier equation to work with. Down below, you could multiply everything by 3. Okay. So just recognize, like, simplify it first. Don't just go through and start trying to isolate something. Okay, so time, distance, speed problems. Before we get into the first question, this is a common triangle that you'll see in math class or in science class. DST, where the D represents distance, S represents speed, and T represents time. And basically, this is how you know how to do your calculations, right? If what you don't know is distance, so you're trying to calculate the distance, that's what we don't know. That means we have to have S and T. We need the speed and the time. S and T are beside each other, right? And when something's beside each other in math, that means multiply. So if you want to calculate the distance, it's always going to equal the speed multiplied by the time. Conversely, maybe you get a different problem that says, how fast is something going? What is the speed it's traveling at? Well, see how if we don't know the speed, we've got the distance and it's on top of time? When you see something on top of something in math, that just means division. So if you want to calculate how fast something is going, you take the distance it's traveling, divide it by the speed it's traveling at. And I think you're going to figure this one out. If you want to find out how long it's going to take, how many hours is it going to take to get there, you want to calculate the time. What you're left with is D over S. So distance divided by speed. Okay. You're going to be using those formulas, those concepts. Generally, like if you know this first one, you can figure out the other two. So we will be using that concept. These problems can be solved in a variety of ways. Okay. So I'll solve them one way. If you see another way, or someone showed you something else, you saw a different video, there are multiple ways to solve these ones. Okay, what I'm showing you is not the only way. First question. She took a 3.5 hour trip from Brownsville to Montreal, which was a total distance of 830 kilometers. She traveled part of the way by bus and the rest of the way by plane. The bus averaged 400 kilometers an hour, and the plane averaged 500 kilometers an hour. How many hours did she spend traveling by bus? Okay, so again, you can start with your variables if you want. How many hours did she spend traveling by bus? I don't know. So I'm going to say B represents the number of hours on the bus. Okay. What else don't I know in this question? No, I don't know how many hours she spent traveling by plane. So I could say P represents the number of hours on the plane. Okay, so what do I know? So the variables, that's what I don't know. The equations are the piece of information I know. What do I know about the number of hours that she was on the bus and the number of hours she was on the plane. We know it took her 3.5 hours. So I could come up with an equation that says the number of hours on the bus, B, plus the number of hours on the plane, P, is 3.5. That equation there represents the time. There's still a lot more information in here. All right. It said the total distance is 830 kilometers. And then the bus travels at this speed. The plane travels 500 kilometers an hour. I know the total distance, so I can come up with an equation that represents the distance. The distance that they traveled on the bus for, remember, distance is speed multiplied by the time. So the distance for the bus is 400 kilometers an hour multiplied by the number of hours they were on the bus. In this case, that's the letter B. So 40, the speed, times the time on the bus represents the distance they traveled by the bus, or on the bus. The plane, the speed is 500 kilometers an hour. If I multiply 500 kilometers an hour times the number of hours they were on the plane, which is the variable P, that's the distance they traveled by the plane, right? So there's the distance traveled on bus plus the distance traveled on the plane. That will equal your total distance. Right, so that blue equation, that equation represents distance. Now you've got your equation. You can solve it using substitution or elimination. You can always choose what you think is more efficient. I'm going to go ahead and do elimination. So I'm going to take my first equation and multiply everything by 40. So we get 40b plus 40p equals 140. Yeah, 140. My second equation, 40b. Oh, I did it again. I did this in the last video. I'm going to erase this so you guys know what I mean. The question wanted me to know how long they spent traveling by bus. If you look at how I did this, I'm going to eliminate the b. But really, I want to solve for b. So instead of eliminating the b's, and it's okay if you do this, you'll do a little bit more work, and that's absolutely okay. Instead of doing this, I want to eliminate the p's. If I can eliminate the p's, then I can solve for b a lot easier. Again, you do not have to recognize this, and if you don't, that's absolutely okay. My first equation now becomes bigger. 500b plus 500p equals 1,750. And the second equation is staying the same. If I line these terms up and I subtract them, I can eliminate the p's. I'll get 460b equals 920. Divide by 460. And you get b equals 2. Do you see what I mean there? B is the number of hours on the bus. I've already solved for it, so I don't need to sub it back in to calculate the answer. I am done. Therefore, she spent 2 hours on the bus. Okay. So how I solved that one, I was able to come up with an equation for time and an equation for distance. We're not always going to be able to do that. And we'll see in example 2, I'm going to do something different. I don't have a lot of room, so I'm going to have to insert another page here. Okay. Sorry. So 2 cruise ships are sailing towards each other from islands that are 264 kilometers apart. One ship travels 4 kilometers faster than the other. If they both start at the same time and meet after 6 hours, how fast is each ship traveling? Okay, I'm just going to put it down here where we have more space. Okay, there we go. No, too big. There we go. Okay. So, I don't know like the total time here. I'm going to set up a table, and I'm going to use this table to organize everything I know. D is going to represent the distance. S is going to represent whatever I know about the speed. T is anything I know about the time. So we have 2 cruise ships. So this can be ship number 1, cruise ship number 1. And this down here could be what I know about cruise ship number 2. What do I know? I know that they're 264 kilometers apart. One is traveling 4 kilometers faster than the other. And if they both started at the same time and meet after 6 hours, how fast is each ship traveling? Okay. So wait, they start at the same time and they meet after 6 hours. That means they've both traveled for 3 hours. No, just kidding. That means they've both traveled for 6 hours. All right, so cruise ship 1 traveled for 6 hours, cruise ship 2 traveled for 6 hours. One ship, something else I know, one ship is 4 kilometers faster than the other. Okay, so I don't know how fast either one is going. Let's say that cruise ship 1, I don't know. When we don't know, we use a variable. So cruise ship 1 is traveling X kilometers. How fast is cruise ship 2 going? Oh, well, it's going to be 4 kilometers faster. Okay, so I'm just going to define this right now. I'm going to say X represents the speed of one cruise ship. Okay. Now, how far did these guys go? I don't know. Like, does the first cruise ship go 200 kilometers or 100 kilometers and the second one goes 164? I don't know how many kilometers each went. But what I know is the total. So the 2 distances will add to 264. I don't know how far each one went. So again, when I don't know something, I can use a letter. So I can say Y. Y is going to represent the distance of the first cruise ship. Okay. Now this, what I'm going to fill in here, might take a bit, so you might need to pause the video and think about this. If the first cruise ship went Y kilometers, and the total that the 2 went together is 264, how many kilometers did the second cruise ship go? Think about this. If cruise boat number 1 went 64 kilometers, how far did the second one go? If the first cruise ship went 100 kilometers, how far did the second one go? What you're doing when I answer those questions is you're taking 264 and you're subtracting the distance the first cruise ship went. You're taking 264 and minusing the distance of the first cruise ship. Now, I don't have any equations yet. The table has helped me organize some thoughts. I'm going to get some equations here. Now, remember that the distance equals the speed multiplied by the time. I can write an equation for that. Y equals x multiplied by 6. We like the coefficient in front. 6 times x. Same thing down below. The distance, so 264 minus y, equals the speed multiplied by the time. Again, I like to put that number in front so I can say time and then the speed. There we go. Now in green, I've got two equations. Down below in black, I have some variables. I can go ahead and solve these equations now. I've got a y equals equation, so substitution is going to be very simple here. I'm going to sub 6x into y of the second equation. And now you've got this equation that we're going to solve. You can expand the brackets. From here down, this is just grade 9 math. Careful with integers, but you should know how to do these things. I'm going to move the minus 6x over. When you move that over, it becomes plus 6x. You get 12 x's. Move the 24 over, so you're going to subtract it. 264 minus 24 is 240. And then divide by 12. X equals 20. Just double checking my math there. Oops, sorry. Okay. The number seemed off, but that's good. Okay, so what did we just find out? X. If you go back to that table, X is the speed of the first cruise ship. The question wants to know how fast is each cruise ship traveling? Oh, well, we just found out the first one. Therefore, the first cruise ship is traveling 20 kilometers an hour. And the second one is traveling. Think about what we know about the speed of the second one. The speed of the second one is 4 kilometers faster than the other. So the second one is traveling 24 kilometers an hour. There you go, and you're done. We don't need to solve for y here. Okay. So this table could actually have been used in this first example here. You'd get very different looking equations, but if we go back to this first example and we set up a table of everything we know, the bus and the plane. We know the bus traveled 40 kilometers an hour, the plane 500. The total distance was 830. We don't know the difference in how much the bus and how much the plane was, so I could use a variable. I could say y is the distance on the bus, and just like on that last one, if the total is 830, the plane then would be 830 minus y, in the same way we had that yellow highlighted section. Okay, and then the time on the first question. The total time was 3.5 hours. I don't know how it was broken up, but maybe there was X amount of hours on the bus. That means it was 3.5 minus X on the plane. And you could get the same correct answers with these equations. Very different than those two equations that we solved with, but you'll get the same answer. That distance, speed, time table can always work. Let's do the last question here then. A canoeist took 2 hours to travel 12 kilometers down a river. The return trip against the current took 3 hours. what was the average paddling rate of the canoeist, and the speed of the current. So think about this question here. This one's different. This one has two speeds working together. So when you're going downstream, you're paddling a bit, but the river's making you go faster, right? The current is speeding you up. If you turn the canoe around, you can paddle the same rate, but the current is going to actually slow your overall speed down. So you've got the speed you're paddling and the speed of the current that's affecting you. I'm going to set up a table. To start sorting out what I know. Okay. So I know, okay, they're going to travel downstream and they're going to travel upstream. It took 2 hours to go 10 kilometers down a river. So 2 under the hours column, 12 kilometers, that's a distance. The return trip against the current took 3 hours. What's the distance? Doesn't tell us explicitly, but you can make an inference. If you're going back, you got to go back the 12 kilometers that you went out. Right? You go 12 kilometers out. To get back home, you have to come 12 kilometers back. What we don't know in this question, and that's what the question's asking, is what's the rate of the canoeist, the speed you're paddling, and the speed of the current. Those are the two things I don't know. Think about that. If you're going downstream, and it's going to take 2 hours to go 12 kilometers versus upstream or against the current, 3 hours. You're going faster here, right? You're going the same distance in a shorter period of time. You're going faster because you've got your paddling rate, which we're assuming it's the average paddling rate. So it's going to be the same both ways. But going downstream, that current is going to speed you up. It's going to increase your speed. So it's going to add to your speed. Going against the current, it's actually going to decrease your overall speed. It's going to take away from how fast you're going. Now that we've done this, you can come up with your equations. Distance equals speed times time. Don't forget to define your variables. So P is the average paddling rate. And C is the speed of the current. To solve this one, you could do a few things. Try to simplify it first. So you might want to expand those brackets out. Or I'm actually going to do something different. I'm going to show you. It doesn't always work, but these numbers work out nicely. If I divide this side by 2, those cancel. And I can divide that by 2 nicely. So that equation would simplify to 6 equals P plus C. Second equation, if I divide a 3 on both sides, it actually simplifies very nicely as well. Okay. Now you've got equations, a P and a C. You can line them up. If you eliminate, some students think both things disappear. If you subtract, your P's will disappear, but not your C's, because a positive C minus a negative C would leave you with 2 C's. Right. Or if you added those, if you didn't do that, and you wanted to add, 6 plus 4 would be 10, P plus P would be 2P, C plus a negative C, now we've eliminated the C's, you can divide by 2, and 5 would be your paddling rate. I'm not going to finish that question off because the solving piece, it's just setting them up. if you see a question that talks about the time, the speed, and the distance of something, you can always set up a table like this and just use the fact that distance equals the speed multiplied by the time. Okay, the table is not your equation, but it is a nice way to organize.